Welcome to this lesson on Charles's law, one of the fundamental gas laws in chemistry. Charles's law describes the relationship between the volume and temperature of a gas. The mathematical expression for this law is V1 divided by T1 equals V2 divided by T2. This formula shows how volume and temperature are directly related when pressure remains constant. Understanding this law is essential for predicting how gases behave when heated or cooled. Charles's law is named after Jacques Charles, a French physicist and inventor who made this important discovery. He identified this relationship between gas volume and temperature in 1787. His work was groundbreaking in understanding the behavior of gases and laid the foundation for modern thermodynamics. Jacques Charles was also known for his pioneering work with hydrogen-filled balloons, which directly related to his studies on gas behavior. Charles's law states that the volume of a gas is directly proportional to its absolute temperature. This means that as temperature increases, volume increases proportionally, and as temperature decreases, volume decreases proportionally. However, this relationship only holds true when pressure and the amount of gas remain constant. These conditions are crucial for the law to apply accurately. In other words, if you keep the pressure the same and don't add or remove any gas, changing the temperature will predictably change the volume. Charles's law can be expressed in two mathematical forms. The proportion form states that volume is proportional to temperature. Written as V proportional to T, this shows the direct relationship between the two variables. The equation form is more practical for calculations and is written as V1 divided by T1 equals V2 divided by T2. Here, V1 and T1 represent the initial volume and temperature, while V2 and T2 represent the final volume and temperature after a change. This equation allows us to calculate unknown values when conditions change. There is one critical requirement when using Charles's law. Temperature must always be expressed in Kelvin, not Celsius or Fahrenheit. Kelvin is the absolute temperature scale, which starts at absolute zero, where all molecular motion theoretically stops. Using Celsius or Fahrenheit will give incorrect results because these scales can have negative values, which would make the mathematical relationship meaningless. To convert Celsius to Kelvin, simply add 273.15 to your Celsius temperature. For example, 0 degrees Celsius equals 273.15 Kelvin. Let's understand the direct relationship between temperature and volume more clearly. When temperature increases, the gas particles gain kinetic energy and move faster. This increased motion causes the particles to collide with container walls more forcefully and frequently, pushing the walls outward and increasing the volume. Conversely, when temperature decreases, the gas particles lose kinetic energy and move more slowly. This results in fewer and weaker collisions with the container walls, causing the volume to decrease. This direct relationship is what makes Charles's law so predictable and useful. Let's work through a sample problem to apply Charles's law. We are given the following information. The initial volume V1 is 2.5 liters at an initial temperature T1 of 300 Kelvin. The temperature is then changed to T2, which is 450 Kelvin. Our task is to find the new volume V2. Notice that both temperatures are already in Kelvin, so we can proceed directly with our calculation. This problem demonstrates a typical scenario where temperature increases, and we need to determine the resulting volume change. Now let's solve the problem step by step. We start with the Charles's law equation. V1 divided by T1 equals V2 divided by T2. To find V2, we rearrange the equation by multiplying both sides by T2, giving us V2 equals V1 multiplied by T2 divided by T1. Now we substitute our known values. V2 equals 2.5 liters multiplied by 450 Kelvin divided by 300 Kelvin. Calculating this gives us V2 equals 3.75 liters. Notice that the volume increased from 2.5 liters to 3.75 liters because the temperature increased, which perfectly demonstrates the direct relationship described by Charles's law.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.